All right, here we have Unit 4, Objective 2, Multiplying and Dividing Rational Expressions. You're going to see that this is very similar to Objective 1. Mostly what we're doing here is just factoring things and reducing. There's just going to be a couple extra parts because there's going to be two fractions now involved that we're either multiplying or dividing. Before we get started, like it says here, multiplying and dividing fractions is much easier than adding and subtracting fractions because, well, when we're multiplying fractions, like it shows us here, if I have a over b times c over d, I end up with a times c over b times d. In other words, we just multiply straight across. That's easy. Nothing needs to match. But if we're adding or subtracting fractions, what do we have to have? Well, we got to have a common denominator. So multiplying and dividing fractions is much easier than adding and subtracting fractions because we don't need a common denominator. So don't need a common denominator. Okay, so that's going to make these a lot easier. That's why we do it before adding and subtracting. All right, instructions for multiplying polynomials. Factor, then cancel and see what's left. That's pretty much it. Okay, and then also keep in mind, since we have a over b times c over d equals a times c over b times d, whenever you're given a multiplication problem, I mean, you can pretty much just do this. Just connect the two fraction bars, and then I got this times that on top and that times that on bottom. Okay, so we don't have to rewrite the whole problem. Pretty much just connect them. Okay, so for problem number one, let me zoom in. Those numbers are written kind of small. We got 4x plus 1 over 5x plus 10 times 30x plus 60 over 2x minus 2. Okay, so basically, I can connect those. I've got the product of these two things on top and the product of these two things on bottom. Okay, and then I would just want to reduce whatever I can. Well, before I reduce, though, we're going to need to factor some stuff. So let's see, 4x plus 1, I can't factor that, so we'll leave that alone. And then 30x plus 60, and 4x plus 1 is put in parentheses, so we keep that thing, by itself. 30x plus 60, what can we take out there? Well, 30 and 60 have a 30 in common, so I can take out a 30. So I'm going to just put times 30. And if I take out a 30, I'm left with x plus 2. Okay, so I've got these three things on the top of my fraction. And the order doesn't matter. A lot of times we'll put the number first, or the monomial first, and then the binomials, but again, technically doesn't matter. And then on the bottom, what do we have? Well, we've got 5x plus 10. I can take a 5 out of there. And then that's going to leave me with x plus 2. Okay, so that's good. I already see a couple things that are going to cancel or reduce. And then 2x minus 2. Let's see, we can take a 2 out of there. And then that leaves me with x minus 1. Okay. All right, and then now that we have everything factored, we just want to see, well, what can we reduce? I've got an x plus 2 on top and bottom, so I can reduce those. Okay. Let's see. On bottom, I've got 5 times 2. 5 times 2 is 10. So this 10 is going to reduce with that 30. The 10 goes away completely. The 30 I'm going to reduce to a 3. Now you can reduce the 30 and the 5 and then separately reduce the remaining number with the 2. But we don't have to do that. Okay, you can just do it at the same time. All right, anyways, that's all the stuff that reduces, and then what are we left with? Okay, well on top we've got a 3 and a 4x plus 1. And on the bottom we're left with just the x minus 1. Everything else that reduced became 1s, we just didn't bother writing the 1s. Okay, so on the bottom we just have x minus 1. And then this is our answer. So again, it's just a bunch of factoring and reducing. And whatever's left is our answer. So a lot like Objective 1, there's just more pieces involved. Okay. All right, problem number 2. We've got this trinomial times this fraction. Okay, well, let's see. This is a little different because normally we're multiplying a fraction times a fraction. Okay, so is this the same thing? Well, sure, it can be. You just want to think of this trinomial as that big thing over 1. So I've got this trinomial on top over 1 times that binomial over that binomial. Okay, so now I got my pieces. Now I want to start factoring everything. W squared minus 8w plus 15. How are we going to factor that? Okay, let's see. I know my signs are the same and they're both negative. I got to have w and w to get w squared. And what multiplies to 15, and since my signs are the same, adds up to 8, 5, and 3. The order doesn't matter. Okay, so I got w minus 5 and w minus 3 over 1 times, and then we've got a w plus 3 here, over 4w minus 20. Well, I can take out a 4 there, and then that leaves me with w minus 5. Okay, and again, since we're multiplying, we basically want to treat this like one big fraction. I've got these 3 parts on top, these 2 parts on bottom, and we don't really need to worry about the 1. And then what are we left with after we reduce stuff? Well, here all we can reduce is the w minus 5. And then we're left with w minus 3 times w plus 3. Over, well, 1 times 4 is just 4. So then that's my answer. Okay. Now you might notice we have something in the form a plus b times a minus b on top. If you want to write your answer in in standard form multiplied out, you get w squared minus 9 over 4. You can, but there's no reason to do the extra work of multiplying that out. Just leave it in factored form. That's perfectly fine. Okay. All right. So again, when we're multiplying two fractions, basically you just factor everything and reduce whatever you can, and then you're done. Okay. Now division problems are very similar. Let me zoom out a little bit so you can see the whole sentence. Instructions for dividing polynomials. Change division to multiplication. So we want to take, how do we do that? We flip the second fraction, then factor and reduce. So there's just one extra step of flipping our second fraction. And then here's the key. Why does that work? So think of the answer to this question. Dividing by 2 is the same as multiplying by what? Okay, so dividing by 2 would be the same as multiplying by 1/2. Okay, and then what is 1/2 compared to 2, which is 2 over 1? 2 over 1 and 1 over 2, well, those are reciprocals of each other. So then we just want to keep in mind that dividing by anything, because this isn't unique to 2, it works for anything, dividing by anything is the same as multiplying by its reciprocal. So if I want to divide this big thing by x minus 1, well, that's the same as multiplying this big thing by 1 over x minus 1. So when we get a division problem, let's zoom in a bit so we can see it better. Like problem number 3 here, I want to take my second fraction, which is x minus 1 over 1, and then flip it, and then it's just factoring and reducing. So instead of this thing divided by that, it's this thing times 1 over x minus 1. Now, to save yourself a little bit of writing, I don't want to rewrite x squared plus 10x minus 11 over x squared plus 12x plus 11. I'd rather write those in factored form. So let's factor these as we're changing our problem to a multiplication problem. So to factor the top, I know it's going to factor into two binomials. My signs are going to be different to get negative 11, so positive and negative. Got to have x and x to get x squared. And what multiplies to 11 and has a difference of 10? 1 and 11, it's a prime number. And my bigger one is positive, so it's going to be positive 11, negative 1. Okay, and then on the bottom, I want to factor this trinomial. So it's also going to be two binomials. My signs are the same, they're both positive. Got to have x and x to get x squared. And what multiplies to 11 and adds up to 12, obviously 11 and 1 again. And now I have those things factored. And then times, and then we want to flip this fraction and make it 1 over x minus 1. Okay? And again, since we're multiplying, think of it as one big fraction. I've got these 3 parts on top, these 3 parts on bottom, and then what can I reduce? Well, I've got x plus 11 here and here. I can reduce those. I've got x minus 1 here and here. I can reduce those. And then what am I left with? We'll put our answer below so we don't go in the next problems area. Now, what am I left with on top? Just the 1 over x plus 1. And then that's my answer. So the division is really no different than the multiplication. There's just one extra step. I got to flip that second fraction. Because again, dividing by anything is the same as multiplying by its reciprocal. Okay? All right. One more on this page. So we got a division problem. Our first step is going to be change this into a multiplication problem. So instead of dividing by this thing, I want to multiply by its reciprocal. So I want to flip this to make it 2x plus 4 over x plus 4. Okay? All right, let's see here. I don't want to rewrite this whole big fraction and then have to factor it and rewrite it again. Let's just factor it the first time. So we've got x squared plus 6x plus 8. That's going to factor into two binomials. we need to have our signs be the same. They're both positive. Got to have x and x to get x squared. And what multiplies to 8 and adds up to 6? 4 and 2. Over, now we want to factor x squared plus x minus 2. That's also going to factor into two binomials. My signs are going to be different, so I'm going to have a positive here. It doesn't matter where the positives and negatives at. You'll see why I did that in a second. I'm going to have x and x to get x squared. And then what multiplies to 2 and has a difference of 1? Well, 2 and 1. My bigger one is positive, so positive 2, negative 1. So I put the plus here because I knew I wanted those on top of each other. Doesn't matter if they are or not. All right, times, and then I want to flip the second fraction. Okay, well, if we flip this, I'd have 2x plus 4 on top, but we also want to factor that. So if I factor this, I can take out a GCF of 2, which would leave me with x plus 2. Okay, and on the bottom, we got x plus 4. Okay, so we flip the second fraction and everything is factored, and now we just want to see what can we reduce. I've got an x plus 2 and an x plus 2. I've got an x plus 4 and an x plus 4. And then what's left? Well, I've got the 2 times x plus 2 on top. Over x minus 1. Can you write this as 2x plus 4? Sure. Oh, excuse me, let me move this up. So again, can you write this as 2x plus 4 on top? Sure. If you want to go through the hassle of multiplying it out, that's perfectly fine. It means the same thing. You don't have to do that. And on the bottom, all we had left was the x minus 1. So here is our answer. Okay. All right, so again, this whole section is mainly just a bunch of factoring and reducing, a lot like section 1. All right, now on the second page, just go right to it here. Keep these to one video again. We're kind of looking at some relationships with fractions. Okay, so number 1 here, a little tricky, let's read it slowly. One of two numbers can be expressed as the rational expression, and again, rational expression just means fraction, okay? A plus 4 over A. Okay, so it says one of two numbers, one of them is that. So I'm going to be working with that, A plus 4 over A, where A is not equal to 0 because that would put a 0 in the denominator, that's no good. And A is not negative 4, because if it was negative 4, it'd be 0 on top, which is okay, but they're just saying it's not 0. Okay, so it's some number that's not 0. And they want us to express a second number if the product of the two numbers is 1. Okay, well, what does product mean? Okay, product means multiply, so I'm going to multiply this thing with something else, and my answer is 1. Okay. Now the key here, how do two different numbers have a product of 1? Well, if I'm multiplying this fraction with something else and the answer is 1, well then how does that happen? Well, basically everything has to cancel, so we're just left with 1s. Okay, so we're going to multiply it by another fraction. Okay, we can always make it a fraction because if it's not a fraction, you can just have a 1 on the bottom. All right, let's see, I want this a plus 4 on top to cancel, or reduce I should say, with something on the bottom, which means on this fraction I have to have an a plus 4 on the bottom. Okay. Also, looking back at our original fraction, can I reduce these a's? No, and why not? Well, because I don't have an a on the top, I have an a plus 4. This is one thing. So keep that in mind. We can only reduce when we're multiplying, not adding or subtracting. Okay, so if I got an a plus 4 up here, I want an a plus 4 down here, so they reduce. And if I've got an a down here, well then I want an a up here so that they reduce. And then yeah, I could cross these off. Technically they don't just disappear. Those reduce to 1s, and these would reduce to 1s. And then 1 times 1 on top is 1, 1 times 1 on bottom is 1, 1 over 1 is 1. Yeah, we're good. Okay, so again, we usually don't bother writing the 1s, but if that's all that's left, it might be a good idea. Okay, so anyways, we found the second number. What was the second number? Well, my first number was a plus 4 over a. My second number was a over a plus 4, which is the reciprocal of our original number. So if I want to multiply two numbers and get a product of 1, then I want to multiply by its reciprocal. Okay? We don't need to write a whole sentence, but let's just put reciprocal so it stands out. Hope I spelled that right. All right. Okay, so that's number 1. A couple more things here. Number 2. express a second number if the product of two numbers is 0. So they're referring to the same number we started with originally, a plus 4 over a. So this time we've got our number, a plus 4 over a, times, because again they're saying the product is 0, times some number equals 0. Okay, well, this number is not 0. They said that originally. So some number that's not 0 times something equals 0. Well, what's the only number that's going to work here? Well, 0, because 0 times anything is 0. So then our second number would have to be 0. So if two numbers are being multiplied and their product is 0, we know one of them has to be 0. And we've talked about that quite a bit when we were solving problems by factoring. We're just kind of saying it here again. Okay, so pretty simple there. Let's move on to the last part here, and then we'll wrap up these notes. Okay, a couple of relationships with fractions that we want to keep in mind. If we have some fraction, x over y, I don't know what those numbers are yet, and this fraction is a number that's bigger than 1, what can you say about x and y? Okay, now don't just think hypothetical with all these letters. That's not very easy. Let's use some numbers. Zoom in so we can see better. Think of a fraction that is bigger than 1. Okay, how about 3 over 2? That equals 1.5. Okay, that's good. Or maybe 4 over 2. That's equals 2. That's bigger than 1, sure. Or 5 over 2. Or 1,000,000 over 2. And it doesn't have to be a 2 on the bottom. It could be anything. But yeah, that equals 500,000. So that's bigger than 1, sure. Okay, well, what do all four of these fractions have in common, other than there's 2's on the bottom, because that wasn't, didn't have to be 2's. But in all those fractions, well, the numerator is bigger than the denominator. Okay, and then anytime that the numerator is bigger than the denominator, then my fraction is going to have a value bigger than 1. Okay, so if x over y is greater than 1, well, then that means that my numerator has to be bigger than my denominator. In other words, x is greater than y. Okay, so again, if you get a problem like this, give yourself some examples with real numbers, and it'll make a little more sense that way. Okay, and then the last one, if x over y is less than 1, what can you say about x and y? Okay, well, again, let's think of some numbers that are less than 1 that are fractions. How about 1/2? Or 1/3? Or 7/8? Because again, it doesn't have to be a 1 on top every time. Okay, and again, we don't need to put any more examples, but we got these 3 here. And what do all of these have in common? Well, here, how does my numerator compare to my denominator? Well, here my numerator is smaller than my denominator. So anytime that my numerator is smaller than my denominator, well, the value of my fraction is going to be less than 1. Okay, so what can we say about x and y? Well, this time x has to be less than y. Okay. And then that's it. So just something to keep in mind with fractions in general. Hopefully that made sense. That wraps up Objective 2.